wondering how to take the integral of a constant? Okay, so this is what we do. We draw out our graph, and now we're looking for the area from 1 to 4 of y of 6, 6 being constant. Now, this is the area that we're looking for. How do we take that area if it's a constant? We can't take the antiderivative. So what we do, this is a simple rectangle, so we just do area. No big deal. Area equals base times height. So our base is 4 minus 1, so that's 3, times our height, which is 6. So 3 times 6, 18. See? No big deal. Now if we had like negative x plus 3, that would be a triangle. So instead of base times height, you would do half base times height and do the exact same thing. Half times the base of your triangle plus your height. And if we had a trapezoid, the area would equal half b1 plus b2 times the height. So really, no big deal. Now this is our basic integral, and it's pretty easy to do. All we have to do is take our antiderivative of this, x squared minus 6x plus 1, and then plug in our bounds and do a little subtraction. So I'll show you how it goes. Take our antiderivative, which is going to be 1/3 x cubed minus 6x, minus 3x squared plus x. You evaluate it from 0 to 2. Now, that equals 1/3 times 2 cubed minus 3 times 2 squared plus 2. Now we subtract our plugins from 0 from this. So we would get 1/3 0 cubed minus 3 times 0 squared plus 0. All this turns to 0. So our answer here would be 8 over 3 minus 12 plus 2. So our answer is negative 22 over 3. And that's the answer to this integral. Now another way to take the integral is to use substitution. And then you're going to use substitution for the harder integrals, because it makes it a lot easier, trust me. So we have our integral, the square root of 4x plus 1. So what we would do, usually you should substitute whatever is under the radical or in parentheses. So let's substitute u equals 4x plus 1. So let u equals 4x plus 1. Then we take the derivative of that, so du equals 4 dx. So let's multiply that by 1/4 so we can cross out the 4 here and bring it over here. So we would have 1/4 du equals dx. So that's what we substitute in for dx. So when we rewrite it, and do 1/4 times the integral of square root of u for 4x plus 1, du instead of dx. So when we do that out, we have to take the antiderivative of the square root of u. So let's go over here, and we would get 2/3 times u to the 3/2. And don't forget to multiply that by 1/4. And since we have no bounds, plus, and 1/4 times 2/3 is 2 over 12, which is 1/6. And then 1/6 times u to 3/2 plus u. So let's rewrite it with our 4x plus 1. Just plug it in for u. So 1/6 4x plus 1 to the 3/2 plus c. And that is our next example. We should take the integral of cosine 7x plus 5 dx. Now since 7x plus 5 is in the parentheses, we'll substitute u. Let u equal 7x plus 5. Then after that, remember, we have to take the derivative of 7x plus 5, so du equals 7 dx. And then multiply it by 1 over 7, so we can get rid of the 7. And then multiply du by 1 over 7, so we can bring it over here. And dx is alone. So we substitute 1 over 7 du in for dx. So we get 1 over 7 times the integral of cosine u for 7x plus 5 du. And then take the antiderivative, so we get 1 over 7 times sine u plus c, since we have no bounds. And sine is the antiderivative of cosine. So all we have to do is plug in 7x plus 5 over here where the u is, and then we get 1 over 7 sine